Batteries are in almost everything we use: our phones, computers, energy storage, and even in transport. Typically, to see how well a battery performs, scientists have to charge and discharge them over and over until ultimately the battery stops working. This can take years of development and testing, plus it's an expensive process. Now, researchers from MIT and Stanford University in America have turned to AI to help. Izzy Clark spoke to William Chu, who explained how AI has stepped in.
Well, what we have done is generated a very large set of battery data. So we have run about 120 batteries 100,000 times, and that created a very large data set. And this data set consists of about 500 million data points. And we use machine learning and artificial intelligence to look for correlations between the lifetime of the battery and signals that the battery will give in its early use.
Oh, I see. So it takes all of that big data that you've got and can, predict what way a battery is going to work, essentially, or whether it's going to work at all or die off very quickly.
That's right. So you can imagine a good battery should last 3,000 times or so. A bad battery may only last 150 times. And these batteries exhibit subtle differences in the first few times that you use it. It's very hard to detect because the correlation is very weak. But what the machine learning does is it looks for those very weak patterns and trying to establish the link. And in this sense, the artificial intelligence is doing exactly what we do, which is to look for patterns. But machine learning is very good at looking for many patterns at the same time. So every single one of these indicators are somewhat weak, but combined, they are very good indicators for the lifetime of the battery. The key to succeeding at this task is, one, to create a very large data set upon which you can generate the correlation and identify the correlation, and then to use an efficient algorithm for doing so. And that's exactly what we have done here.
Okay, so if you give it, a bunch of batteries, you don't know their lifetime or how they might work, hopefully your system will then sort all of that out. But if you know the long life or the short life, what can you actually do with that information?
Well, the use cases are really quite tremendous. One example is to shorten the time of research and development. So when battery manufacturers come up with a new battery chemistry or a new manufacturing process, you should test those on real batteries. And when you do that, you will want to cycle the battery to failure to see how well the battery will last. So one use case of our innovation here on early prediction algorithm is that the manufacturer would just run the battery a couple of times or maybe 100 times. Then you would get a reasonable estimation of its lifetime. The second use case, which I'm particularly excited about, is to use this algorithm to aid with the manufacturing of batteries. And you can use that data to sort the battery into several classes. You can have a grade A battery, a grade B battery, a grade C battery, not very different from how eggs are sorted. So this sorting process allows good batteries to be grouped together to yield a battery pack that would have very good performance. And the reason is because the battery pack performance is often limited by the weakest link inside the battery. And likewise, you can group the not so good battery together, maybe your class B battery, and those batteries maybe can be sold for less demanding applications. For example, electric vehicles are very demanding applications, and consumer electronics are less demanding applications.
But if this system, say, shortens that test period, is there any safety implications on that? Are you still able to find out if there is going to be a defect in your battery?
Yes, absolutely. So we're looking for early signs of safety failure as well, but without having the safety event occurring. Batteries pack a lot of energy. This is why when batteries fail, it tends to fail in a catastrophic way. So if we have some way, some sort of magic ball to look into the future of battery that includes not only lifetime, but also safety, this can really help with overall adoption of battery technology in new areas such as electric vehicles.
Will Chu from Stanford University there, and that work has been published in the journal Nature Energy.